Yo guys, what's up? I'm back with another video on calculus. So this is basically an integral problem. Looks quite complicated, but don't worry, we'll get around with that. Right? So to get started, let us look at the function of what we have to find the integral of. So we see that this is kind of a mirroring problem. So when I say a mirroring problem or a mirror thing, it's like there is repetition of certain numbers or variables. So we have 2 raised to x that is repeated. So whenever there's something like this, we go for substitution method. So now the question comes, what will we substitute? So let us divide the given function into 3 terms for a convenience. So the first term is the most complex one, the 2 raised to 2 raised to 2 raised to x. Second term is 2 raised to 2 raised to x. Third term is 2 raised to x. And yeah, with respect to dx, we are integrating this thing. So the most complex one is the starting one, the first term, that is 2 raised to 2 raised to 2 raised to x. So just let this 2 raised to 2 raised to 2 raised to x be z, right? So the second step is finding the derivative of z. Now to go around with the derivative, we need to know two things. So the first one is the chain rule. Now chain rule says that whenever you have to find the derivative of one function related to another function, say function 1 that is f of x and function 2 that is g of x, and the derivative of what we have to find is f of g of x. So in this case, we just let g of x be some random variable. So we get derivative of f of, say the variable is t, so f of t. And we find the derivative of f of t, and then we find the derivative of g of x. So in this case, it is a function raised to another function. And it's not just one function raised to another function. It is a function raised to a function, raised to a function, and raised to variable. Let's call that as well as a function, just for convenience sake. So we have these three functions contained in a single term. Now the second thing you need to know is derivative of a raised to x. So that is a raised to x into log of a. That's quite straightforward. So let's move on to derivative of z. So let us write d of z with respect to d of x. I'll just get the value of z down for a convenience sake. Now let's consider the blue bubble contains as 2 raised to 2 raised to x. So we have this a, which is 2 raised to some variable, that is 2 raised to 2 raised to x. So deriving this, we get a raised to x, in this case it's 2 raised to 2 raised to 2 raised to x, into log of a, that is 2. So that's the first part. Now deriving the contents inside the blue bubble, we have 2 raised to 2 raised to x. Now 2 raised to x is another variable, we will say. Let's green bubble it. So we get 2 raised to the contents of the green bubble, that is 2 raised to x into log of 2, base log of a. Now the ending part is 2 raised to x, the green bubble contains. So we take that and we derive that, and we get 2 raised to x into log of 2. So in the next step, basically we are opening the bracket and all that stuff, and we get this complex thing. I'm not going to say that, that's tongue twister. Right, now what we do is we kind of arrange the terms, rearrange it, and we get d of z divided by log of 2 raised to 3 is equal to this complex right hand side. Now if you see, the right hand side is actually the function of which we have to find the integral, right? So let's just integrate on both of things, right? So here, so we see the right hand side is basically our integral, and we can say that our integral is equal to the contents of the left hand side in the previous equation, that is integral of d of z divided by log of 2 raised to 3. So we get this. Now this, I think, ends up as a quite simple integral. We have the constant 1 by log of 2 raised to 3, and derivative of z is basically z. So we have z divided by log of 2 raised to 3 plus c, that's a constant, the integral constant. So substitute the values for z, and here you are. That's the answer basically. And we are done. So I hope you have enjoyed this video and learned something new. See you in another video. Suggest something in the comment. I'm out of ideas, so take care.